Assalamu alaikum. Bismillahirrahmanirrahim. In the name of Allah, the most beneficent and the most merciful. Guys, today also I'm going to solve a questions related to domain. The question is so complicated, but if you know the graphs of the question, then the question will be so easy, right? So I'm going to write down the question here. The question is, find the domain of fx which is equal to square root log base 0.4 x minus 1 divided by x plus 5. This is the question, okay? And then you have to find the domain of this question, right? So as you know, here you can see it has two functions. It involves two functions. The first one, you can say the square root function. The another one is logarithmic function base 0.4. Here you have to notice that the base is 0.4, right? So I'm going to solve this question first. Okay, so as you can see, the question is fx log 0.4 x minus 1 x plus 5, right? Okay, so first of all, as you know, this is a square root function, and for the square root functions, this function is defined when the whole thing here, you can see this one, if you see this one, the whole thing, okay, considered to be a x, right? When this x log base 0.4 x minus 1 divided by x plus 5, if this value, if log base 0.4 x minus 1 divided by x plus 5, must be what? 0 or greater than 0. This is a very important point, right? So if this value is 0 or greater than 0, right, then you can say the function exists. Okay, for this condition, now you can say it has just one logarithmic function. Okay, here how will you solve these questions? So remember one thing here, the base is 0.4, right? So I told you the graph of a logarithmic functions, you can see here. I'm going to draw a graph of logarithmic function. Okay, for example, if you have a log base a x, okay, but here this a is greater than 0 but less than 1. A is greater than 0 but less than 1 means the value of a is lying between 0.1, 0.2, 0.3 to less than 1. Okay, so the graph is always like that. Okay, the graph is always like that. Okay, remember I told you in the graph of logarithmic functions you must know two important points, right? So the first point, you can say here, this is the first point, right? This is the first point. I'm going to write down this point as a. Here the coordinate is always 1, 0, right? Means if the value of the x is 1, then the whole function is 0. Second, as you know, this value is what? A is greater than 0 but less than 1. Here you can see our base is 0.4. So 0.4 must be here, right? Okay, so if 0.4 is here, so if you draw a vertical line here, you will say I got another point which is B, right? Okay, so here we can find out the coordinate point. X is 0.4 and the y is always 1. these 2 points are very important point for solving questions of logarithmic functions, right? So I got this point, and this graph continuously goes up. Okay, so this is the graph of log base ax, where x is greater than 0 but less than 1. Okay guys, here if you see in this question, if you see, we need this value, right? This is the range, you can say the whole value, we need it. We need this value 0 or greater than 0. Remember, this is very important. If you understand this basic concept of logarithmic functions, even the question is so hard, it would be so easy for you. Okay, so log base 0.4 x minus 1 divided by x plus 5 must be 0 greater than 0. So it's so very easy. Just have a look on this graph and just tell me where this function is 0 or greater than 0. So right guys, you can see this is the red one, is the graph of log x, right? So you can see here in this case, if x is greater than 0, see, this is greater than 0, this is 0, this is greater than 0 and less than 1, not less than 1 or equal to 1. Okay, if you are here only from 0 to 1 here, okay, if you are here, the function's value is always 0 or greater than 0. Look, you can see if you are from 0 to 1, if you are here from 0 to 1, the functional value is always positive, right? Only at the time of 1, this function value is 0, and I want 0 here. So if you are here between 0 to 1, the function value is always up. And remember one thing, if you are going to take the value of x which is greater than 1, you have always the functional value which is always negative values, right? So for this condition, we can say if this function exists, if x minus 1 divided by x plus 5, this one must be what? Greater than 0 but less than equal to what? 1. So if this value is greater than 0 and this value is what? 1 or less than 1, means if this value, for example, if this is 1, right? So if this value is 1, then you can say this value is 0. So if the value of x minus 1 divided by x plus 5 is greater than 0 but less than or equal to 1, then we are 100% sure that the functional value will be always 0 or greater than 0. Okay, now we have to solve this question. So guys, I'm going to solve this question. Okay, you know why I'm just posting a lot of questions based on domain? Because only the chapter domain will give you a lot of information in mathematics, right? If you don't have the concept of the basic things, I think you cannot solve the question. So just only solving 2 questions, 3 questions, 4 questions of domain, don't understand that you have the master skill in mathematics. No. So now I'm saying that 0 and 1, we want the value of x minus 1 divided by x plus 5. As a mathematics teachers, I know now it's so complicated to solve this inequality, but if you know the graphs, right, this question must be so easy. Now I'm going to tell you these things. I'm going to solve this question by 2 ways, one by graph and second by normal way. Okay, so here I'm going to raise this one. Okay, now you can see here x minus 1 divided by x plus 5. Okay, so if you know how to draw the graph of x minus 1 x plus 5, right? Okay, guys, if you have any rational function, right, and you must know only 4 things. So if you know these 4 important points, just 4 important points, right? Vertical asymptotes, horizontal asymptotes, x-intercept, y-intercept, enough. Then the graph is ready for this function, right? Okay, so as you know, vertical asymptote means, what is the meaning of the vertical asymptotes? Vertical asymptotes are nothing, these are the zeros of the denominator, right? So you have x plus 5, so what will be the 0? X is equal to minus 5. Minus 5 will be always here, right? This is vertical asymptotes, which is what? Minus 5, right? Okay. Horizontal asymptote, if you see here, this one is this degree and this degree is the same, right? For example, here you can say x the power is 1 and here x the power is 1. If this is the same, then you can say you have to take the coefficient of numerator as well as the denominator, right? So here what is the coefficient? 1. Here is what? 1. So 1 divided by 1 means 1. It means your horizontal asymptotes is 1. Horizontal asymptote is the horizontal line, so this is, you can say, plus 1, right? So you can say this is the vertical one, this is the horizontal one, right? Okay. Now what is the meaning of the vertical asymptotes and what is the meaning of the horizontal asymptotes? Okay, in simple words, whenever you have a vertical asymptotes in a function, it always tells you only one information: the left side and the right side. I'm sorry, the right side and the left side. The function has positive infinity or negative infinity, or negative infinity or positive infinity, or both side positive infinity or both side negative infinity. Doesn't matter. It always had unbounded behavior, right? So it always give you infinity values. Okay, 80% cases you will see the positive infinity and negative infinity, where the right hand means the value which is very close to the vertical asymptotes. For example, here this is minus 5, right? So if you take x is equal to minus 4.99999, you will see it has the positive infinity or the negative infinity, right? The graph is always coming from the up or coming from the down. Okay, so this is the vertical asymptote, and the horizontal asymptote means what is means you can say that in the behavior, right? When x goes to positive infinity or x goes to negative infinity, when what is the functional value of a given function. So I will make the chapter of the vertical and horizontal asymptotes. So right now I'm going to give you just one idea, that this one you can say y is equal to 1. Y is equal to 1 is the horizontal asymptotes, and x is equal to minus 5 is the vertical asymptotes. This means when x goes to positive infinity, means you can say here in this function, you can say x is equal to 100, 200, 150, 250, 500, 700, 10, 1000, million, billion, whatever. The function value is always 1. The graph will never cross the 1, but the actual value will be 1 here. So this is 1 and this is what? Minus 5. Okay, now I want the horizontal, I want the x-intercept. X-intercepts are nothing, these are the zeros of numerator. So you have x minus 1. So what is the 0? X is equal to 1. So you can say this is what? You can say this is what? This is 0. Okay, this is numerator. This is x-intercept. So I got the x-intercept. Now y-intercept means just put x is equal to 0. Okay, if you have an equation, then you have to find the vertical, you have to find the y-intercept. Just put the value of x is 0. So if you put 0 here, you have minus 1.5. You can say minus 1 by 5. So now we have a point here A, you have a B, and you know the vertical asymptote. So it's so easy to make the graph. And now see, so this is minus 5. So the graph is always go like this one, right? You can say the graph is always be like this one. Okay, because if the graph comes here, it cannot cross the horizontal asymptotes. So obviously the graph will go this one. It will exercise this one, right? And after then this is what? Negative infinity. And then here you can say the graph will be always, it will never cross the horizontal asymptotes, right? Okay, so now this is a very clear graph of the given function. And now my dear, if you see, I want the value of x minus 1 divided by x plus 5. I want the value which is greater than 0 but less than or equal to 1, only 0 to 1. So you can say, if you have here, right, if you are here, see the graph, if you are here, see, and if you are going these directions, right, means if the x is what? 1 or what? Less than what? Positive infinity, you can say. If the value of the x here, you can say the value of x is 1 or less than 1, your graph is always here, right? Okay, if the value of x is what? 1 or less than 1, then you can say x minus 1 divided by x plus 5 is always what? 0. or what, less than 1. You can see very simple equation. Okay, you can see this inequality. If the value of x is 1, at 1 this function is 0, right? 0, right? And if x is what, from 1 to positive infinity, like 2, 3, 4, 5, 6, 7, 8, the whole rational functions lying between 0 to 1, right? So as you can see, the domain, so the domain of this function is, okay, so the domain of the given function is from 1 to positive infinity, right? So if the value of x is from 1 to positive infinity, the rational function x minus 1 will be always from 0 to 1, right? It will be from 0 to 1, right? Yes, if you are going to take this one, x is 1 to positive infinity, you can say this value will be what? Either 1, not 1, less than 1, and this will be what? Greater than equal to 0 here. This function is 0 and x is equal to 1, right? So you can say it's always from x minus 1, x plus 5 is always 0 to 1. Here you can say we don't want 0, right? You can say this is x minus 1 and this is what, x plus 5. So x minus 1 divided by x plus 5, see, x minus 1 divided by x plus 5 is always from 0 to 1. So this is 0. Here you can say this is 0, this is 1, right? So this is what? So we can say this value is always 0 to 1. So if this value is from 0 to 1, here, if we put here 0 to 1, okay, 0 to 1, we want this inequality is 0 to 1, right? So if this is 0 to 1, then we can say this function what exists. So the domain of the given function is 1 to positive infinity, right? Okay, the second point, if you say no, I'm not going to solve by the graph, okay, can you please explain me manually how to solve these questions? Okay, so you can see here, okay, so normally if you say this value is what, from 0 to 1, okay, here we can take two cases, right? So number one, we can say normal x minus 1 divided by x plus 5, this is what, greater than 0, right? So x minus 1 divided by x plus 5. Can you tell me the cases where this function has this just positive values, right? You have just two cases here, sir, just two cases. Number one, this is positive or this is positive. So if this is positive, then the function is positive, right? Number one. Number two, if this is negative, so negative, negative, positive. So we have just two cases, okay? So we will just make two cases here, case one. And it will take time, okay? If you are not going to solve this question by the graph, then it will take time, okay? So case one, I can say case one, if x minus 1, okay, if is positive and x plus 5 is positive, and these two values are positive, then the whole functions give you the positive values. So now this means what, x is greater than 1, and this means what, this is what, minus 5, okay? If you draw the graph here, okay, so you can say this is 1 is here and minus 5 is here, right? So we want to take the common values. They said that in these cases, this is what, greater than 1. Greater than 1 is here, right? This side. And minus 5 is this side, right? So if you are going to take here, it's not the common portion. If you are going to take here, it's not a common portion, right? Okay, and if you are here, this is a common portion. This satisfies this inequality as well as this one. For example, if I take 5, so 5 is greater than 1 as well as 5 is greater than minus 5. So the question is, the inequalities lies, you can say here, x belongs to 1 to positive infinity. So if you have x1 to positive infinity, then we can say this function is positive here. We can say this function is positive, right? Okay, number 2, as you know that x minus 1, x plus 5 must be, you can say this will be what? 1 or less than 1, right? Okay, this means what? Greater than 0. Greater than 0 means what? You have 1, 2, 3, 4, 5, 6, 7, 8. But I don't want a lot of values of this function, right? We want the values of x minus 1 divided by x plus 5, which is 1 or less than 1. So what will you do? So here, you can say, I'm going to solve this question, case 2. Okay, so you can say the first one. Okay, wait, I'm sorry. I'm going to solve this question first. So this is what? X minus 1 less than 0 and x plus 5 is less than 0. In the first case, you have taken what? These two, right? The positive. Now I'm going to take negative. Okay, so if you say here x is what? Less than 1. Okay, and this is what? Less than minus 5, right? So x is less than 1 and x is what? Less than minus 5. So if you say less than 1 this side, okay, this one this side, okay, and less than minus 5 is this side, it means the common portion is here, right? For example, if you say minus 10, okay, if you say minus 10 here, right? So minus 10, if x is minus 10 is less than 1, right? Minus 10 is less than minus 5, this is also right. So here, for this one, you have x belongs to what? Minus infinity to minus 5. You have these two cases, okay? In case, the whole is case 1. If you consider the whole cases is what? Case 1, okay? In this case 1, we have to categorize case 1 and case 2, right? So we can say in case 1, we have this one and this 2, okay? Now we have to find case 2 and then we will check it, right? Okay. Okay, this one is done, right? Now x minus 1, x plus 5 must be what? 1 or less than 1, okay? So as you know, guys, x minus 1 divided by x plus 5 cannot be 1, right? Because the horizontal asymptote is what? 1, and for the horizontal asymptote, the graph cannot cross it, okay? So I'm going to solve here. You can see x minus 1 divided by x plus 5, and this is what? Minus 1, 0. When you solve this question, you have x plus 5, x minus 1 minus x minus 5, so plus minus cancel, you have minus 6 divided by x plus 5 less than equal to what? 0. Means we want this value we want this value here 0 or less than 0, okay? 0 or less than 0, minus 6 or less than x plus 5. So guys, this value, if you see, right, if you are going to draw this graph, okay, we want what? Here you can say from 1 to positive infinity, we have the value which is what? Between 0 to 1. The functional value is 0 to 1, right? Okay, and from minus 6 divided by x plus 5, this is the second cases. As you know, when I made the graph the first time, I said to you it has vertical asymptotes at minus 5, right? This was the minus 5, and this was your horizontal asymptotes, right? So, and I said to you the graph is always like this one. It means if you are here less than minus 5, it means the function value is what? Greater than 1. I don't want the greater than 1. I want this value is less than 0. Less than 0 means the negative values, right? And this was your 1, right? This was your 1. Okay, so the graph start like this one. So as you can see, I'm just going to give you the basic idea for this one. So the vertical asymptote, right? So you can see here, according to this question, okay, according to this one, when this conditions is satisfied, okay, so you can say if this value this value we cannot say minus 5, right? Because it has the vertical asymptotes. So we can say Alhamdulillah. Now, according to this one, if you are going to draw these graphs, okay, so when this value is satisfied, when the value of x is from -5 to positive infinity, you can say, if you can take any value from -5 to positive infinity, for example, if you are going to take 0, so 0, 6 divided by 0 plus 5, this function exists, right? I mean, this function is satisfied. If you are going to take, by example, any values like 20, so this part is positive, this negative, so this is always negative and this condition is right. But if you take -10 this side, then -10 plus 5 is what? 2, right? -2, so minus cancel. So you can say 6 divided by something, so this value is what? Not satisfied. Okay, so for these cases, the domain of this function only is -5 to positive infinity. Okay, this was the case 2. Here I'm going to mention here, this was the case 2. Okay, case 1 was from 1 to positive infinity. We mixed this one and we told you the first case, the domain is 1 to positive infinity. In case 2, I said -5 to positive infinity. So can you please tell me that what if you combine this, what is the common portion? So -5 to positive infinity, 1 to positive infinity. So you can say the common portion start from 1 to positive infinity, right? Here is -5 to positive infinity, and this is 1 to positive infinity. Then we can say the real domain is 1 to positive infinity. So here so here you can say the domain of given function is from 1 to positive infinity. Guys, as I told you, when you solve this question by graph, okay, it will be so easy to solve this question, okay, that I already solved it. So, but if you want to solve, because one more thing, if you solve manually, it will give you a lot of information, right? So it's not my intention to solve the question and post this on YouTube. No, I want to give you information how to solve one question by different ways, right? So this is our second way of solving this question. So the domain is from 1 to positive. I hope guys you all understand. Still, if you have a problem, you can just write down the comments. Whenever we have a time, I will reply you. Take care. Bye bye. Assalamu alaikum.